In this video, we will learn what is the average rate of change and what is mean by rate of change. This is the section 1.2 rate of change in AP Precalculus. Okay, so let's see what is mean by average rate of change. So imagine you are driving a car. So the distance from starting point to ending point, you covered some distance, right? Now take um, the change in distance over the change in time. This gives the change in distance over change in time, that is the average speed. Right? If you, but Hi, so in this video we will learn the concept of rate of change and average rate of change. So this is the section 1.2, the rate of change in precalculus. Okay. Let's learn the what is mean by average rate of change. The average rate of change is change in output values over change in input values. That is nothing but we can denote this with a delta y, that is the change in output, over delta x, that is the change in input. So the delta y is, that is the difference between the y coordinates, that is the y2 minus y1 or x2 minus y2 minus y1 or y1 minus y2. We generally written as y2 minus y1 over delta x is the change in the x values, that is the x2 minus x1. You can see this is the slope formula, right? The slope. So that is, which is a slope. So the average rate of change is just the slope of the secant line. Now let's see this problem. So find the average rate of change between 1 comma 2 and 3 comma 4. Okay, you can see 1 comma 2, this is the graph of this function, negative 1 half x square plus 3x minus 1 half. So at 1 we have the corresponding the y value is, you can see from the graph, it is approximately this. At 3 we have approximately this point, right? So that is 1, this is the 1 comma 2 and this one is 3 comma 4. Now the average rate of change is just the slope of the secant line which is passing through 1 comma 2 and 3 comma 4. The secant line which is passing through 1 comma 2 and 3 comma 4. So the average rate of change is ARC. Okay, so this is equal to y2 minus y1 over x2 minus x1. So here this one is x1 y1, this is x2 y2. So that is the y2 is nothing but 4 minus 2 over x2 minus x1 is 3 minus 1. So which is, so 4 minus 2 is 2 and 3 minus 2 is 1. Sorry, 3 minus 2 is 2, that is the 2 over 2 is just 1. So that is the slope of this secant line is 1, that is the average rate of change. Here you can choose the this point as a x2 x2 y2 and this one is x1 y1. You can use the formula, you will get the same answer. Now let's move to the second problem. What is the average rate of change of the interval from 13 to 25? So you can see at 13 we have the corresponding y value is 76. At 25 we have the corresponding y value is 30. So this one is x1 y1, this one is x2 y2. So now the average rate of change is, that is the A or C, equal to y2 minus y1 over x2 minus x1. So from the table y2 is 30 minus y1 is 76 over x2 is 25 minus x1 is 30. So this is equal to 30 minus 46, 30 minus 76 is negative 46 over 25 minus 13, which is 7 plus 5, that is the 12. So 7 plus 5, that is the 12. So this is equal to negative 46 over 12, or you can simplify this one. So 12, so this one is 12 threes, and we have the 10 over 12 or negative 3, the 5 over 6. So this one is the average rate of change between the 13 to 25 seconds. Now let's move to the next one. So here you can see the word pair in this problem. What is the average rate of change in the interval 13 to 25 seconds means here the distance is measured in meters and time is measured in seconds. So the average rate of change is, it is a meter per second. The units are here the meter per second, right? Now here the meter indicates, here you can see in these units, the first unit is the meter, that indicates the dependent variable. Okay, so the word per is the key indicator that you are dealing with the average rate of change. The miles per gallon, students per classroom, online games per server, it tells you which variable is dependent and or independent, as the dependent is always listed first. Okay, yes. Now let's see the rate of change at a particular point. Okay, so the rate of change at a particular point is called that is the instantaneous rate of change. You will learn this uh, in our calculus. So let's see what about the rate of change of a function at a point. So this tells about the rate at which the output values would change or the input values change at a point. Okay, not an interval, at a point, at a particular point. What is the change in output value? So that is called the rate of change. So we can approximate the rate of change at any point, at a point, by using the average rate of change over a small intervals, okay, that contain the point, right? So this is nothing but the slope of the secant line is the rate of change, and the slope of the tangent line gives the rate of change, and the slope of the secant line gives us the average rate of change. Now let's estimate the rate of change. Okay, estimate the rate of change at x equal to 1 for this function negative 1 half x square plus 3x minus 1 half. Okay, so we have to approximate this at x equal to 1. So we have to choose a small interval. Okay, so let's choose x equal to x1 equal to 1 and x2 equal to, let's say, add some more, a small interval 0.1, right? So this one equal to 1.1, and find the corresponding y values. So the corresponding y values are So that is y1 equal to, you can use the calculator and plug in, you can use the calculator and plug x1 equal to 1, you will get the corresponding y1 value, and here you will get the corresponding y2 value, right? So let's use the calculator. Okay, so we have y equal to, so this one f of x, right? So y equal to, we have, let's enter y equal to negative 1 half. So you can use the parenthesis negative 1 half plus 3x minus 1 half. You can see, I think we have to, we forget the x square here. So second insert, let's add x, let's clear this. So y equal to, so the parenthesis negative 1 half times x squared plus 3 times x minus 1 half. When you crop this is the parabola. So we have to find the value set to y equal to, okay, so second, at x equal to 1 and at x equal to 1.1, you can use the values here. So y1 of 1.1, that is the corresponding value is 2.195, and y1 of 1 is, it is 2. Now so we have to find the difference, right? That is the y2 minus y1 over x2 minus x1. So this is the y2. So the y2 is, this one is the y2 minus y1 is, this is the y1 over x2 minus x1. x2 is 1.1. So x2 is 1.1 minus x1 is 1. Okay, you can see this is the estimated rate of change, the average rate of change. Okay, but we are taking very small interval, right? So this is the estimated the rate of change. If you take the smaller and smaller interval, you will get the better and better rate of change. Okay, so here the average rate of change is the rate of change, the estimated rate of change is 1.95. Okay, so the estimated rate of change, so that is y2 minus y1 over x2 minus x1. So that is approximately, here from the calculator it is 1.95. Now let's move to the next problem. So the fourth one, try it on your own. Find the approximation for the rate of change of g at x equal to negative 2 and g of x equal to e to the x. Okay, so you can see at the function e to the x is something like this. So this is the e to the x. So we need to approximate the function value, sorry, the rate of change at x equal to -2. Let's say this one is -2. So that is the slope of the tangent line, right? The slope of the tangent line. So to find the slope of the tangent line, we can take some point, let's say the nearby point. Let's say this one is -1.9. Right. Now let's find the average rate of change of these 2 points. You will get the estimated rate of change of this one. So that is the A or C, the average rate of change between the y2 minus y1, that is the g of -1.9 minus g of -2 over x2 minus x1, that is the -1.9 minus 2. So you will get so this is e power -1.9 minus e power -2 over, so this one -1.9 plus 2, that is the 0.1. You can use the calculator and plug these values. So let's plug this one, clear this one. So we have the e to the x, so second e to the x. Now okay, I'll clear this one. So this one is y2 minus y1, that is the where -1.9 minus e to the -2, that is the y vars of -2. Okay, so this is the, sorry, so we have to use this minus here. Yeah, so this is the difference of the y values. Okay, so we have to find the difference of x value, so that is the 0.1. So we have to divide this value with 0.1. So divide by 0.1, we will get, that is the 0.14, this one. Okay, so let's see. Okay, you can see, so the estimated rate of change is, this is approximately 0.14233. Approximately this is the estimated rate of change. The average rate of change is when we take the intervals smaller and smaller, we will get the average rate of change becomes the rate of change, that is the instantaneous rate of change. We will get the better and better instantaneous rate of change. Now let's move to the next one. So now we have a positive rate of change indicates that one quantity increases, the other quantity also increases. A negative rate of change indicates that as one quantity increases, the other quantity is decreases. Okay. Now let's see. State whether the situation represents a positive or negative rate of change. As the years increases, a high school student body increases. It is true, right? Okay, as the, let's say we have the, let's say this one is t, and the, let's say this is the body. As the time increases, there's the number of years, so you will grow, the students will grow, right? That means it is an increasing function. As the Mr. Bean's weight decreases, his running distance increases. Okay, let's find out. Let's see what happened here. He is running. This one is running. If the running is increases, okay, the body's weight. Let's say Mr. Bean's body weight. What happened if running increases, burning more calories, right? It means the body weight is decreasing. It is a decreasing. Okay, now let's see. So find the average rate of change of the function on the interval h of t equal to 3 to minus t square over the interval 2 to 5. So that is the average rate of change ARC is so h of 5 minus h of 2 over 5 minus 2. So what is h of 5? So h of 5 is 3 times 5 minus 5 squared minus 3 times 2 minus 2 squared over 5 minus 2, which is just 3. So 3 times 5 is 15, 15 minus 25, which is negative 10, minus 3 times 2 is 6, 6 minus 4 is 2 over 3. So this one is negative 10 minus negative 2, that is negative 12. Negative 12 over 3 is just negative 4. So the average rate of change is negative 4. Here b of w equal to w plus 2w over the interval negative 1 comma 2. Okay, so find the average rate. So that is the ARC equal to b of 2 minus b of negative 1 over 2 minus negative 1, which is b of 2 is 2 plus 2 to 2 squared minus 2 2 plus 2 power minus 1 over 2 minus of minus 1, which is 3. So 2 plus 2 square, that is the 2 plus 4, that is 6 minus, so 2 plus 2 inverse, that is 2 power negative 1 is, so that is the 2 plus 1 half, that is the 2 plus 1 half is, that is the 5 half over 3. So 6 minus 5 half is, so this is the 12 half minus 5 half, that is the 7 half. 7 half over 3, that is the 7/6. So the average rate of change is 7/6. Now let's move to the next problem. We have f of x equal to ln of 3x over the interval 1 to 4. So the ARC, the average rate of change is f of 4 minus f of 1 over 4 minus 1, which is f of 4 is ln 3 times 4, which is 12, minus f of 1, which is ln 3 times 1, which is 3, over 4 minus 1, which is 3. So ln of 12 minus ln of 3 is, which is ln of 12 over 3 over 3. That is ln of 12 over 3, which is ln of 4, right? So ln of 4 over 3. So this is the average rate of change. Now let's move to the next problem. So use the information in each table to find the average rate of change on the given interval. So from this table, so the interval between the interval 3 to 55, what is the average rate of change? So 3 to 55, the corresponding y value is 5, and here the 55, the corresponding y value is 143. So the average rate of change is y2 minus y1, that is the y2 is 143 minus y1 is 5, and x2 minus x1, which is 55 minus 3. So that is nothing but, so 143 minus 5, which is 138 over 55 minus 3, which is 52. Okay, So this is the average rate of change. You can use the calculator and simplify this one. And 10 to 43. So between 10 to 43, at 10 we have the y value is 102, and 43 we have the y value 140. So the average rate of change is y2 minus y1, which is 140, minus y1 is 102, over x2 minus x1, which is 43 minus 10, which is 140 minus 100, which is 40, so that is the 38, and 43 minus 10, which is 30. So this is the average rate of change. You can use the calculator and simplify this one. And the last one we have, so the average rate of change between 21 to 55. So that at 21 we have 135, and at 55 we have 143. Therefore, the average rate of change is A or C. So y2 minus y1, that is the 143 minus 135, over x2 minus x1, which is 55 minus 21. So 143 minus 135, which is 8, and 55 minus 21, which is 34. So 8 over 34 is the average rate of change. So this one you can use the calculator and approximate this. Now let's move to the next problem. Here we have given t is in months and d of t is in hairs for the follicles. Here we forget the units. Here the t is in minutes and d is in meters. So the units are here meter per minute. Here the meter per minute. Okay. Here also meter per minute. Now let's see, here the t is months is given and d of t is the hair follicles is given. So as the, and we have the table of values are the given. So we have to estimate the number of hair follicles per month. Okay, between 6 to 48 months. So the corresponding hair follicles are 20,000 and 48 is 10,000. So the average rate of change of the hair follicles between 6 and 48 is, that is the 48, at 48 we have the 10,000, minus at 6 we have the 20,000, over 48 minus x2 minus x1, 48 minus 6, which is negative 10,000 over 48 minus 6, which is 42. So that is, you can use the calculator here. So that is the negative 10,000 over 42, which is negative, approximately it is 2381. That is the negative 2381. That is the hair follicles per month. Hair follicles per month. Here 13 to 72, 12 to 72, we have the corresponding y values are 19,800 to 72, we have 7,500. So that is the average rate of change is y2 minus y1, which is 7,500, minus y1 is, which is 19,800, over, that is the 72 minus 12. Okay, so you can plug into this and find the value. So that so this one is, so we have 7,500 minus 19,800 over 72 minus 72 minus 12, so which is negative 205. That is the hair follicles per month. And let's see, so between 6 to 72, so between 6 we have, so this one is the 6, it is the 20,000, and 72 we have the 75,000. So the average rate of change between 6 and 72, so the ARC is, that is the 7,500 minus 20,000 over 72 minus 6. You can use this and plug into this calculator. So you have the 7,500 minus 20,000, which is negative 12,500 over 72 minus 6, which is 66. So negative 12,500 over 66, which is equal to approximately negative 189.39, which is 4 molecules per, or you can round it to the 189 hair follicles per month. Now let's estimate the average rate of change of the function at the given point. So we have the function, we have to estimate the average rate of change. So that means we take the, at x equal to 4, to estimate the rate of change, let's take some small interval nearby this 4. So let's use this is x1 and x2 equal to 4 plus we have to add some 0.001. Okay, so the x2 value is 4.001, is smaller nearby value. Now let's estimate the corresponding y value. So y1 and y2. So the y1, you can use the calculator here. So we have 1 over 3x 3 times x so y1 equal to here I have plugged y1 equal to 1 over 3x. Now let's find the corresponding y1 values. So that is y was y1 of 4. So the fourth value this one, and y2, so let's use the y2 equal to 4.001. This one is y2. Now take the difference between y2 minus y1 over x2 minus x1. So that is the let's say y2 minus y1. So this is the y2 minus y1 is, or you can use this one, minus y1, which is y1 over x2 minus x1. The x2 is, so that is the 4.0001 minus x1 is 4. So the average rate of change is, so that is the estimated rate of change, that is the negative 0.02083. Okay, so this is the estimated rate of change. So the rate of change equal to approximately this one. Okay, and this is the y1 value. So this is the y1 and this is the y2, and you can plug these values into here. So and find the formula y2 minus y1 over x2 minus x1. Okay, plug these values into, you will get the y1 equal to 0.0833333 approximately, and y2 equal to 0.83331250. Okay, and plug these values into the calculator, you will get these values. And the formula we have, the rate of change equal to, so that is the y2 minus y1 over x2 minus x1, the estimated rate, this one equal to y2 minus y1 over x2 minus x1. So you will get this value, negative 0.020832. Here we, so now let's move to the seventh problem. So we have to estimate the average rate of change of the function at this point x equal to negative 2. So we have this function, right? So this is the 2x squared plus 1. So the graph is something like this. So let's say we have this is the 2. So the average rate, the estimated average rate of change is the slope of this tangent line. Okay, so let's choose at x equal to negative 2. So we find the nearby point. Let's say x1 or x2 is, let's say this is x1 and x2 equal to, the nearby point is, let's say, negative 2.00001. Okay, now let's find the corresponding y values, y1, y2. So let's use the calculator and find the corresponding y values here. So y1 is, which is 2 times negative 2 whole square plus 1, which is 2 times 4 plus 1, which is 9, and y2 is 2 times negative 2.0001 whole square plus 1. So using calculator, so which is 9.000 0.08. Now the estimated rate of change, that is the ARC, is approximately y2 minus y1 over x2 minus x1, which is 9.00008 minus 9 over x2 minus x1, which is negative 2.00001 minus negative 2. So which is 0.00008 over, which is negative 2 point. So this one is so negative of positive 2 means which is negative 0.00001. Okay. So using the calculator, otherwise this one is we have the same decimal, right? So this is equal to negative 8. So that is the approximated rate of change is negative 8. Actually this is the exact rate of change, because we are using a very small interval, that's why we get the exact rate of change. Okay, now let's move to the next problem. So we have f of x equal to 7 root x, and we have to estimate the rate of change at x equal to 2. So we have to estimate at x equal to 2. Let's take the a nearby point x2, that is the 2.01. So the estimated range of, let's evaluate the corresponding y values. So y1 and y2. So the y1 is, that is the 7 root x, 7 root 2, and y2 is, that is the 7 root 2.01. So the estimated rate of change is, so the ARC, which is the approximately the rate of change, so that is the y2 minus y1 over x2 minus x1. So that is 7 times 2.01 minus 7 root 2 over, so 2.01 minus 2. So which is, so you can factor the 7 here, that is the 2.01 minus square root 2 over, so 2.01 minus 2, which is 0.01, which is equal to, so which is approximately 2.47179. So that is the estimated rate of change. Now let's move to the ninth one. So we have this function, we have to estimate the rate of change at x equal to 3. So let's choose x1 equal to 3 and x2 equal to, take the nearby point, let's say 3.01. So find the corresponding y values, y1 and y2. So this one is ln of 2 times 3 is ln of 6, and here this one is ln of 3.01, that is the ln of 6.02. So the ARC is the estimated rate of changes. So that is the ln of 6.02 minus ln of 6 over, so 3.01 minus 3, which is 0.01. So using calculator, so which is approximately 0.33277. Okay. State whether the situation represents the positive or negative rate of change. So a candy company uses pins of the chocolate to make the candy. The more chocolate they use, the more boxes of the candy is produced. So you can see the more chocolate they use, the more boxes they produce, right? So this is the positive rate of change. You can here see the amount of money Josh saving account decreases for each semester he attends the college. So here the rate of change is decreases. As the number of cats Mr. Sullivan owns increases, the number of mice in his barn decreases, right? So decreases. So the number of cats increases, the number of mice in his barn decreases. So that is so it is a negative rate of change. So this one are the cats and this one is the mice. So if the cats are increases, the mice will decrease. As the amount of water Mr. Brost drinks decreases, the fewer trips to the restroom he needs to take. Yes. If he doesn't drink, if he drink less water, the fewer trips to make. So this one is the negative. And final question we have. So a continuous function f is defined on the closed interval -5 -5 to 5 less than x less than 6 is shown in the graph for how many values of b. So that is the -5 less than b less than 6 is the average rate of change of f in the interval b to 5 is equal to 0, and give the regions. So b is between -5 and 6. So the average rate is equal to 0 means, so at this point we can see that we have the tangent slope. So the average rate is 0 here. Okay. So that is the only point we have. At one point we have the average rate of change, or the rate of change, average rate of change or the rate of change equal to 0.